Have you ever dropped a feather and a stone at the same time? You'll see the stone hit the ground first, every time. But what if I told you they fall at the same speed in a vacuum? Why does this happen? Let's explore the incredible physics behind this mystery. Let's start with the basics. What is a vacuum? A vacuum is a space completely devoid of matter. No air, no gas, no molecules, nothing. It's a space where there's no air resistance, no wind, no sound, just emptiness. In real life, a perfect vacuum is almost impossible, but space and specially designed vacuum chambers come pretty close. On Earth, when you drop a feather and a stone, the feather falls slower. That's not because it's lighter, it's because of air resistance. The feather has a large surface area and low mass, so air pushes back against it more. The stone, being denser and heavier, cuts through the air easily. This resistance slows down the feather more than the stone. But what happens in a vacuum where there's no air to push back? In 1971, astronaut David Scott performed an experiment on the moon. He dropped a feather and a hammer, and they landed together. Why? Because in a vacuum there's no air resistance. The only force acting is gravity, which pulls both objects down equally. According to Galileo and later Newton, all objects in freefall accelerate at the same rate regardless of mass when there's no air. That acceleration is 9.8 meters per second squared near Earth's surface. So in a vacuum, feather equals stone equals hammer equals bowling ball. Now let's talk about how different things behave in a vacuum. Light travels perfectly in vacuum. In fact, the speed of light in vacuum is 299,792,458 meters per second, the fastest anything can go. Sound, however, cannot travel in vacuum. That's because sound needs particles to vibrate. No particles, no sound. So, in space, you can see explosions but you can't hear them. So next time someone says the heavier object falls faster, you know the truth. In the presence of air, air resistance changes the game. But in a vacuum, gravity is the only force in play, treating all objects equally. If you enjoyed this science mystery, hit like, subscribe, and share this video with your curious friends. More mind-blowing science is coming your way.